So here we go, let's start reviewing. You cannot possibly get what you need on this piece of paper, so get out another sheet to write on to keep your work neat and organized. So, we're going to go ahead and do problem number 1. All right, ready? Tell me what this means. What is the purpose of this? To let me know what quadrant it's in. That's exactly right, Donovan. And do you know which quadrant that is? Three. For those of you that are wondering what Donovan's talking about, and he is right on target, remember in math land, not the compass, but math land, angles are labeled like this. Well, in radians, that's half a pi, a whole pi, and 3 pi over 2, and 2 pi. Those are the labels in radians, right? So half the way around is 180, so that would be 90, 180, 270. So when it says between pi and 3 pi over 2, we're talking about a triangle right here. And in that triangle, we're told that the cosine is -2/7. Why did I put the -2 and the 7 where I put them? Because cosine is adjacent over hypotenuse, right? So what am I going to do now? I have to find all the rest of them. So what will I do?
You need to find the opposite.
I need to find the other side, and I will do that using the Pythagorean Theorem. So let's go ahead, try the Pythagorean Theorem. What do you come up with on that third side? Please do it right. Remember that the legs squared have to add up to the hypotenuse. So it equals hypotenuse squared. So it's going to equal 49. Izzy? Square root of 45, which actually, Izzy, reduces or simplifies to 3 square root 5, 9 times 5. Not only that, what else do I have to pay attention to? It's actually going to be negative. And why is it negative? Down. But now I should be set to go. So the sine is going to be -3 root 5 over 7. Which makes the cosecant 7 over -3 root 5. I'll fix that in a minute. Tangent is negative, oh actually it's going to be positive, isn't it? Because it's 3 root 5 over 2, -3 root 5 over -2, so it'll be positive. And that means the cotangent is 2 over 3 root 5. And the secant will just be -7/2 because it's the reciprocal of the cosine. Now, let's rationalize those ones that have radicals in the bottom. So, let's see. This one right here, remember we just multiply top and bottom by root 5. So that's 7 root 5. Now watch it. What do these two make? 5. So that's -15. And similarly here, it'll be 2 root 5 over 15. Okay? Guys, we're doing this sheet for a reason. It's called Pretest. All right, evaluate the secant of 11 pi over 7. The little star there, I don't think I put my super secret code on here. The little star means use a calculator. So we're going to find the secant of 11 pi over 7. Now, be careful. two things. First of all, how do I put a secant into my calculator?
1 divided by
1 divided by cosine. Second of all, 11 pi over 7 is a radian. So make sure that you are in radian mode. And then do 1 divided by cosine, 11 pi divided by 7. So 1 divided by cosine, 11 pi divided by 7. And what'd you come up with?
1.49.
4.49395? Actually, I'll put 4. Is that what you said, Alexis?
Yeah.
Okay. Second tangent, negative 2/3. We can just type that one in, can't we? So second tangent, negative 2/3. Did you get negative 0.588? What's the unit on that?
Degrees.
Not degrees, not unless you changed your calculator. That is a radian. That angle, this is an angle, this notation means angle, and that's radians. Now, could I have done the problem in degrees? Absolutely, but I would get a different answer. There's no, it doesn't matter which one you do it. It could be radians or degrees. If you do it in degrees, it's negative 33.69 degrees. And either one is fine. They're both totally fine. Just remember that your calculator's going to spit it out in whatever mode you're in.
So like on a test, if you give us that, will you ask it in radians?
Well, I don't know. If I want it in radians, I'll have to tell you to do it in radians because there's nothing in the problem. This problem does not indicate whether it should be degrees or radians. So if I put answer in radians, then that's your answer. If I say answer in degrees, that's your answer. If I don't put anything, then either one's fine. All right, now we're going to do a sketch, which you did on the quiz you just took, and hopefully you did great. All right, so it looks like it's ready to go. Give myself a little more room to work here. What does this tell me?
What position?
The phase shift, the horizontal shift, where my curve is starting. So my curve that used to start at the origin, remember a sine curve starts at the origin? Not now. Now it starts at pi over 4. The shape is the same, so I'm going to go ahead and sketch in the shape. I know the amplitude is 2. What about my horizontal labels? Well, here to here is the period, right? A period. What is the period of this particular equation? Pi, because period is found by taking, for a sine, period is found by taking 2 pi and dividing it by that number. So the period's pi, which means that from here to here is pi, which is 4/4, right? 1 pi. So I'm going to start at 1/4 and add 4/4. So I'm going to end at 5/4. You end one period after you start. Now, right in the middle of 1 and 5 is 3. And right in the middle of 1 and 3 is 2. And right in the middle of 3 and 5 is 4. Now, I know that some of those reduce. You're welcome to reduce them, but you don't have to. There's enough to worry about there. You don't worry about the fractions. So my amplitude is 2. My period is pi. My horizontal or phase shift is pi over 4. My vertical shift is 0 because there's no number out here. Remember, if I want to lift it or lower it, I have to put a +5 or -2 or something on the end. And then frequency is the reciprocal of the period. So if the period's pi, the frequency is 1 over pi. Got it? All right. Now we're going to find the exact value of the tangent of 2 pi over 3. What does exact mean? No calculator. You could type that in on your calculator just like we typed this one in, but you won't get an exact answer. You'll get some decimal that you'll have to round off. We want the exact answer. So what do you think we should do here to get going on this? Okay, and how do I change it to degrees? Pi is 180. Divided by 3 is 60 times 2, so is this 120? Now, I'm erasing my setup right here, but that is the setup that I am going to use to draw 120 degrees. So 120 degrees is going to be over here like this. Because isn't it between 90 and 180? This angle right here is the key to the whole shebang. How big is that angle? 60. There's nothing to memorize there. You just have to think about it. If this is 120, then it's 60 more to get to 180. 180 minus 120. Well, if that's a 60, then this is a √3, that's a 1, and that's a 2. And that guy's negative. We want the tangent. Tangent is opposite over adjacent. So the answer will just be negative √3 over 1 or negative 2. Easy enough? Lots to do, but easy. All right, find the area of the shading. And we know that's 140 degrees, and the radius is 2. Anybody have a thought?
Change the rating to degree.
What?
Change the degree to a rating.
You could. In this problem, you don't need to. When you need to, Donovan and everybody else, is if you're finding arc length. I'm not finding arc length here. I'm finding area, which is a different thing. Now, you actually can use the arc length to find the area, but it's harder than just finding the area straight up. What's the area of the whole circle?
360. 360.
No. A revolution is 360. So the angle for the whole circle is 360. But I said, what's the area of the whole circle?
2 pi.
What?
Pi r squared.
Well, pi r squared, and since r is 2, the area of the whole circle would be 4 pi. Pi times 2 squared. That's the whole thing. So if I said, what's the area of half the circle, you would say 2 pi, right? Well, I don't want half the circle. I want 143/60 of the whole circle. Would you agree with that? The whole thing is 360. I don't want the whole thing. I don't want half of it. Half of it would be 180. I want 140/360. That's the fraction of the circle that I want. So of always means multiply. I'm going to get rid of those. So I have 14/36 times 4 pi. That's the area of the piece that I want. The piece that I want is 143/60 of the whole, which I reduce to 14/36. It reduces even more if you want. So that's 64/36, 64 pi over 36, which is 16 pi over 9, is that right? Oh, that's not 64, that's 56. Which is 14 pi over 9, here we go, that's better. 14 times 4 is 56. So the answer is 14 pi over 9. So for future reference, what was the strategy? Binary the whole thing, and then just take whatever fractional piece of it you want, which in our case was 140/360. If that angle was 100, it'd be 100/360. All right. Write the equation of a sine and a cosine curve. So in other words, the thing I just erased, you're going to write an equation of that for this picture that I drew. So remember that a sine equation has 4 potential numbers in it, and so does a cosine. Now look at the picture that I drew here in the paper. And when you look at this picture, do you see a sine curve in there anywhere? I hope you do. A sine curve is a hill and a valley. So when I look at this, and there's more than one in there, but the one my beady little eye spot is this right here. Would you agree that's a sine curve? What's its height? 3? So I know that for that sine curve, this would be a 3 out here. And because it's not starting where it's supposed to, this is going to be x plus pi over 10. Everybody okay with that? It's been backed up. Now, I didn't do a very good job of labeling in that picture, but this is -3 down here at the bottom. So if this curve is oscillating between 3 and -3, has there been a vertical shift?
No.
So you can either leave that blank or put a 0 in it. Whatever you want to do. Now, what is the period supposed to be? 2 pi. I don't think it is. It looks like the period is how much? From the beginning of the red to the end of the red is 1 period. So that's -1/10 to +3/10. How far is that? 4/10. So your picture has a period of 4/10, which you can think of as 2/5, right? Now think about the one that we just graphed. We had the equation. To find the period of it, think if you have your own equation. If you have an equation, y equals 5 sine 7x. To find the period, don't you take 2 pi and divide it by that number? So I have no idea what this number is. But apparently, when I divided 2 pi by it, I got 2 pi over 5. Because that's the period. So what does that number have to be? That's an easy one. Usually we have to cross multiply and stuff, but that's an easy one. What does n have to be? 5. So this number's a 5. That's what would make the period 2 pi over 5. Now, the good news is, everything in this is going to stay the same. This is going to be a 3, this is going to be a 5, and that's going to be a 0. None of that's changing. The only thing that changes is, if you look at this as a cosine, then you're not looking at the red. The red is a sine. If you're looking at it as a cosine, could I look at the orange? Would that be a cosine?
Yes.
And if I look at that particular orange piece, there hasn't been a shift because it's starting exactly where it's supposed to, right? Now, somebody else might look at a different piece. Could you start here and look at this piece right here? Yep. That would be upside down, but you could look at that piece. All right, anybody have a question about that? Yep.
If you're just in a test or quiz and you had wrote down the second equation for the cosine, that would be correct, or some how to put it?
No, this is a right cosine curve. There are infinitely many answers to this problem, but these are the two that kind of make the most sense.
I'm just saying, like with the zeros and stuff, there's no other way to write it that you would need for a test.
No, you can leave the zeros out. So if you wanted to write this as just 3 cosine 5x, that's fine. That's what it is. When I set my equations up, I always just automatically put in the blanks, and so, but you don't have to do that. All right, let's solve an equation now. Guys, please don't be bored. We have a test coming up. We have a test on Friday. All right, so here we go. We're solving this equation. It says I can use a calculator, and it gives me this direction. First of all, that tells me my calculator better be set in degrees. Those are degrees. And secondly, it tells me that my answers can be found all the way around. So I might get more than one answer to the problem. So let's solve it and see. This says 3 tan equals 17. So tangent equals 17/3. Would you agree with that? So somewhere out there, there's an angle whose tangent is 17/3. Now, you can go ahead and label, but it won't do you any good, so I'm not going to do it. You can if you want. We need to find that angle. So what do I press on my calculator to find the angle? I know you could do the Pythagorean Theorem and all that crap. We don't need that this time. We need the angle. Alexis?
Second tangent.
Second tangent, yep. The only way to find an angle is to use your second tangent, second sine, second cosine, whatever. So second tangent, 17/3. Make sure you're in degrees. Did you get 79.99? Second tangent of 17 divided by 3. Got a nod? Okay. So one of my answers is 79.99. Are there any other angles that would have a positive 17/3 tangent? What about here? Would this tangent be positive here? No, because it's opposite over adjacent, it would be positive over negative. What about down here? Would this angle have a positive tangent? Yes, because it's negative over negative. So now I've got the same triangle down here. But the answer isn't 79.99 again. This answer is between 180 and 270. This answer is this angle. How do I find that? Exactly, so add 180 to that. So 180 plus 79.99, which is what, 259.99? Just to, cross all of our T's. Could I have a positive tangent down here? No. Opposite over adjacent would be negative. So these are my two answers to the problem. Number 8's the same thing, except look at the directions. What do those directions tell you? I'm in radians now. Yep. All right, let's hang with me here, guys. Let's get this problem done before the retreat people have to leave. So 4 cosine x plus 3 equals 4. All right, let's solve it. So 4 cosine equals 1, cosine equals 1/4. Everybody okay with that? I'm in radians. I'm going to go to my calculator. But first, where can that happen? All the way around, where can the cosine be positive? 1, for sure 1. Guys, everything's positive in 1. So definitely in quadrant 1. Where else is cosine positive? 4. How do we know cosine's positive in 4? Because cosine is x. Cosine goes with x. So that's positive down here. Okay, so now I'll go to my calculator. Set it in radians, and then second cosine 1/4. Whoops. Second cosine 1/4. Everybody okay with that? And I got 1.318. When do I have to use second cosine? When my job is to find the angle. Okay. Everybody still with me? So what are the answers to the problem? That one's one of them, right? 1.318. And then this blue one, and how will I find that? I'm in radians, so please don't say 360 minus.
2 pi minus.
2 pi minus, very good. So 2 pi minus that angle, I got 4.965. All the way around in radians is 2 pi. So do you get why this is 2 pi minus 1.3? All right, we're going to continue on. You keep reading, have a good retreat. Get ready to watch some videos. Maybe I'll be doing them from prison by then. Okay, gang? Because this sheet is your test review. This is what we need to know how to do. Okay? Number 9. In which quadrant is the cosine negative and the sine negative? If you are confused by the notation, remember less than 0 means negative. So just write negative. So in which quadrant, what are you doing back there, babe?
I was taking a picture of my brother.
Oh, okay.
So he gets his pictures up there.
Yeah, his picture is up there.
Yeah.
That's good. Okay. So where is it that the cosine and the sine would both be negative? How do I know, or how do we know, how did Alexis know it was quadrant 3?
Because both x and y are negative.
Exactly. You guys, you have got to think about cosine as x and sine as y. Now, I am not telling you that cosine is the actual x value. I'm saying they are related, so they have the same SIGN. So if cosine is negative, that means x is negative. If sine is negative, that means y is negative. And the only quadrant where they're both negative is quadrant 3. Find the exact value of the angle whose sine is negative root 3 over 2. This is a tricky one, because you have to remember where the inverse sine is negative. All of the inverse functions, that's what these are called, the inverse functions, if they're positive, it's quadrant 1. That's easy. All of them are there. But if they're negative, there are different rules. Does anybody remember, or can you look it up, wait in your notes, where the inverse sine is negative? Abby?
Quadrant 4?
Yes. So whatever angle we're talking about one in quadrant 4. Those are things you just memorize. That if they're positive, they're 1. That's easy. Anything's 1 if it's positive. But for the inverse functions, sine and tangent negative are in 4, and cosine negative is in 2. Okay, you need to know that. All right, so anyhow, I'm in quadrant 4, and the sine is root 3 over 2. So you're doing this without a calculator, so you recognize that's a 60. And while you might say, oh, the answer is 300, actually it's not. Inverse functions, negative like that, have to be defined as negative. They go down. So the answer to this is actually negative 60 degrees. If you type this problem into your calculator, it would say negative 60 degrees, if you're in degrees. All right, so that requires a little piece of additional memorization that you just flat out have to memorize. Inverse sine is negative in 4, so is tangent. Cosine is negative in 2.
So the negative, that means go down.
Yep.
Okay.
Yep. When you go down to measure your angle, that's a negative angle. Now 11 is kind of the same thing, but a little easier, because you're not actually finding the angle. That's a positive number, so I'm going to draw it in quadrant 1. Anytime you have this picture, or this notation, guys. If that's positive, you're in 1. Okay, no questions, no changes, it's always 1. Now, the tangent of that angle is 3/4. Does that make sense to everybody? So let's do the Pythagorean Theorem. What's the missing side going to be? 5. 16 plus 9. Now, without a calculator, do I have any idea how big this angle is? No. But I don't care. I want to know its cosine, and that I can see. What's the cosine of this angle? Adjacent over hypotenuse, so 4/5. So the answer to that problem is simply 4/5. This one, I had to find the angle for, because that's all I have. This one, I got an angle, but I don't care what it is, I want to know its cosine. This was on the quiz you just took, and it also was in that homework that was a disaster that we talked about last time. So, find the period of each piece separately. So what's the period of this one? 2 pi divided by 1/2, which is 2 pi times 2, or 4 pi, right? So the period of that piece is 4 pi, which means that it starts over again every 4 pi. So 4 pi, 8 pi, 12 pi, 16 pi. I don't care how many you write out. I don't care if you write them out at all. That's what's happening. That's what it means to have a period of 4 pi. Now, what about this half of the problem? Well, its period will be 2 pi divided by 2/3, which is 2 pi times 3/2, which is 3 pi. So that one starts over at 3 pi, 6 pi, 9 pi, 12 pi, 15 pi, blah, 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 blah. Well, I like to write them out because then I can see the first time I have a match. Where do I have a match? Right here and right here. So the period of the sum, if you were to graph this picture, it's going to look very different, it's going to look weird, but it will repeat every 12 pi units. Whatever the weird shape is, it'll repeat every 12 pi. All right, any question about that? Okay, now we have some word problems. And these are all calculator problems. So we'll need our calculator and draw a picture. Charles is perched in the top of a tree. It's 32 feet tall. So up here's Charles. His angle of depression to his book is 23 degrees. How far is Charles from the book? Where do I put the X? How far is Charles from the book? Where does it go? On the hypotenuse. You guys, come on. Literally, read the problem literally. Where is Charles? Where is the book? The distance between my fingers is how far apart they are. What is this distance? I heard some of you talking about this distance. That's the distance from the book to the base of the tree. And in what we were asked. All right, let's finish this one. So, got my picture set up. Now I need an equation. Sine, cosine, or tangent always. Sine, and we know it's sine because this is opposite and this is hypotenuse. So sine 23 equals 32 over x, right? So x sine 23 equals 32, and x equals 32 over sine 23. I have no idea how our calculators were set, but it better be in degrees. This is a degree problem. You've got to always keep an eye on that, guys, always. Keep an eye on that. So, what is it? 32 divided by sine 23. 81.9 feet. Charles is 81.9 feet from the moon. Okay? We'll finish that. When will I see you again tomorrow? Next day? Whenever I see you again, we will finish.